I'm Jose Cano. I'm a lecturer in the University of Glasgow, and today I'm going to introduce our project MAISE. This is a collaboration with HT Microelectronics and also Cisco Scotland. So in addition to myself, here today is my postdoc, Farkina Das, and we have two more academics from Glasgow, Jeremy Singer and Sailo Kio, and Christos, which is an undergraduate student that is working this summer with us, and also we have two engineers from ST, Danilo Pau and Munia. Right, so let me introduce our project as answering or asking a few questions. So the first one is, okay, what is multimodal AI-based security? Let me split this thing into halves. The first one is introducing multimodal AI, which is a new approach that considers different types of data, like images, or text, or voice, and also different types of intelligent algorithms. So the idea here is that considering these different points of view, we are going to have a more performant system. And by performance system means more accurate, faster, or consuming less power. Okay? The second half is AI security, which is basically combining tools and techniques which intelligently and autonomously are able to detect and also react against several types of attacks, or cyber attacks, or any types of cybersecurity threats. That's the first question. Then we have the edge. What is the edge? Or what is edge computing? So as we know, edge computing broadly means moving the computation from the cloud to the very end or very close to the end of the internet. And this implies using different types of devices, ranging from tiny microcontrollers attached to sensors to big systems like driverless cars or satellites. And in the middle, we have systems like phones, tablets, robots, drones, and so on. So well, how do we do that, right? So how can we enforce secure performance system at the edge? So we have observed a main research gap, right? And this gap, basically, we have observed that for different applications like speech recognition, image classification, image detection, we have several models, and I'm showing here a few of them. And yet they provide the required accuracy, high accuracy, but we can see that they require minimum 3 to a few megabytes of space. So that is the problem. We want to deploy our models in tiny MLs, very constrained microcontrollers, mainly provided by our partner ST Microelectronics, right? So the main problem we have there is that the capacity of these systems, these devices, is maximum 2 megabytes. So how can we deploy these models, being robust against attacks, and at the same time perform? That's the main question this project wants to ask. How can we secure, optimize, and deploy multimodal AI models on constrained edge devices without losing the accuracy? Okay? So this is what this project is about. So the objectives we have to achieve that objective is, first of all, optimize the AI inference models. So we know that we can obtain, optimize and constrained models that can be deployed on constrained devices. Can we have these models also robust? No. So we need to optimize. So rather than having two different problems, we need to look at the problem from 2 points of view and putting them together. That's the first thing. So let's imagine that we have this model that is deployable on a constrained device and also secure and robust. Is this the end of the story? No. Why not? Well, because as we know, these systems today are evolved. Okay? So we need to basically update the system with new data, but also with new attacks, right? Because we can be robust today, but not tomorrow, right? So what we basically want to do is to update the system, and we need to retrain, right, the system and eventually deploy it at the edge securely, right? So we also need mechanisms to deploy the model securely. We want to demonstrate these with real use cases. We are having in mind autonomous systems and also smart environments like offices, any type of environment. So as I mentioned at the beginning, it's going to be multimodal. We are thinking about audio and images and separately, and then we will put them together. So just to show you a few techniques that we are using to achieve our objective. So first of all, we need to get deployable systems, models. We are using tools like TF-Lite or OpenVINO. This is Vino, not V, sorry. And then we need to provide defense on the models, right? And here there are a few techniques like transforming the inputs, also change the architecture to be robust, and also training the models with other set of examples, right? And finally, all this thing needs to be secure, encrypted, and deployable in a secure way, right? So yeah, this is more or less the overview of our project.